Let's go to question number 2. So here we have another set of data. You can see lots of data here. So it is up to 41. And then in each of them, we have 36. Okay. So try to find the average torque of the engine production company. So if I go to the next slide and then see that question 2. So we have population of cars, car engines. And then from this population of car engines, selected, it was how many samples? Then we had 41 samples. Okay. And then each sample has a 36 measurements. Okay. This one we call it as N, and this one we call it as M. Okay. Samples are also called the subgroups. Okay. Measurements are also called the observations. Okay. We have 36 observations, and then we have 41 samples. Then the question says that using central limit theorem, find the population average. Okay, the first one, part A. The central limit theorem, it says that the grand average is almost equal to the population. This one is the grand average, and this one is the population. This is the first part of the central limit theorem, and the second part says that the standard deviation of the average is the population standard deviation by the square root of n. And then for this one, so this is the second part of the central limit theorem. So this one is the part A, and this one is the part B. Okay. So let's start firstly from the X bar. So grand average, how we are going to solve it. So first I will find the average of each sample. So for my first sample, I will find the average of it. Okay, let me zoom. This is the average of sample 1. Similarly, I will find the average of all samples. So let's put it as average of sample 1. So I will do the same for all of my samples. And then I will find the average of all the samples. Okay. This is the first part of it. Second part is the grand average. Or we have the X bar. So that one will be the average of the averages here. Okay. So this one is the grand average. Okay. So the first part of the question has been solved. The first part saying that what is the population mean, and the population mean is that the same as the grand average. So that will be 49.95. So mu will be approximately 49.95. This is part A. And then B part comes. What is the, so draw the histogram for this one, but we have to use the BNAS 45 to 55. Okay. Let's do that. So this is the data that I have. And then, so I will just go to data and then data analysis. And then I will draw histogram, and then input range is this one. This will be my input range. And then the bin range. So we have to insert the bin range. Let's do that. So the bin range, first one says that put it yourself. So it will be from 45 to 55. So 45, 46, 48, 55. And then the time is now draw the histogram for it, and we will have the input range. And then I will have the bin range. Okay. And then the output, I will want it as a new worksheet, and then the chart output, you have to select it. Okay, as you can see, this is the, okay, this is the chart that you will get at the end. This is the histogram of it. So next is that to find the population standard deviation. So before moving the histogram, so it must be according to central limit theorem. So the histogram must be the normal distribution. Okay. And then part C comes the population standard deviation. For this one, I will use the formula here. So it will be that the S, then sigma by N. And this one is the population of the car engines. And the N is the 36. So it will be a question, the square root of 36. And this will be the standard deviation, STD of the X bar values. Okay, so if I do that, this one is actually very simple, so you can do it in Excel yourself. So we need to calculate the standard deviation of this sample average, STD of sample average. So that will be the STD samples from this one till the end. So 2.057. So then sigma will be approximately 2.057 times the square root of 36. Okay, this is the C part. And then D says that is the histogram in part B normal distributed? Yes, it is. It should be actually, as I said, according to central limit theorem, it must be normally distributed. And with the 95% confidence, what is the upper and the lower limit of the torque of the engines? So this one is the part E. So it asks the 95%, the upper limit and then lower limit. So for this one, again, we will use the control limit, the normal distribution chart. So this is our normal distribution. And then the mean value is mu, and that is 49.95. So this one is 49.95. And then if you remember, I said in our previous slides that previous actually classes that 1 sigma here and then 1 sigma. So 1 sigma and then 1 sigma. This part, this is 68%. And then you have the 2 sigma here, and then you have 2 sigma here. So we have 2 sigma here. We have 2 sigma here. So this part is a 95%. So 95%. So confident that, so any car engine has torque of, so it will be mu, then plus, and then minus, and then 2 sigma. So 2 sigma is the 95%. So it means that I can say this one is also, you can say 95% of the whole area. Okay. So if the whole area is 1 and 95% is included, covered in this negative 2 sigma, actually this one is negative 2 sigma to positive 2 sigma. So if the question says that 95 confidence, then you have to use the plus minus 2 sigma. And the sigma value is here. So it is 2.5057 times square root of 36. It is so 12.3. So it will be that the mu value is 49 plus 0.95, and this part is 2 times 12.3. So it will be that it will be 49.95 plus minus 25.2. Okay. That is what the question asks. And this is the question number 2. And then the question number 3, we can do that.